Okay, so this is going to be Chapter 1, Section 8, and we are talking about inverse functions. Now, an inverse function is going to be denoted f of inverse x. That's the way we would read this, or inverse f of x. And the way we want to show that two functions are inverses is that we would compose them together, and the results of both directions composing them together would equal x. It's a lot easier to understand this with an example, so we're going to dive right into an example. And here we're given two functions, f of x and g of x, and we want to show that each function is an inverse of each other. So I need to do f of g of x, and then I need to do g of f of x. And if both of those equal x, then that means that these are in fact inverses of each other. Okay, so let's see here. We have f of g, so f is my outside function first, so 4, and then my x minus 7, and I'm plugging in g of x inside, so x plus 7 over 4. And now these 4's here are going to cancel out, and we have x plus 7 minus 7. Those cancel out, and we're left with x. So if this one got there, then now we need to check and make sure that this one does the same thing. So now g is our outside function, so I have x plus 7 over 4. And we're plugging in f, our inside function, and f is 4x minus 7. And we really don't need these parentheses here now, so I have negative 7 plus 7. And now I have 4x over 4. And the 4's cancel, and I'm left with x. So since I got x on both of these, then that means that these functions are inverses. Now, what if I give you one function and I ask you to find the inverse? Well, these are the steps that we're going to go through. First, we'll replace f of x with a y. They really mean about the same thing. Then we'll switch our x and y, and then we'll solve for y, and then we'll write it back into function notation. So let's look at an example. I have f of x equals 7x minus 5. We want to find the inverse. So first, replacing that with y, switching x and y, and solving for y. So adding 5, dividing by 7, and now we have our inverse. The only thing left is to write it back into function notation. So inverse f of x is equal to x plus 5 over 7. Okay. Looking at the next one, we have x cubed plus 1. So first thing I want to do, switch this into a y, and switch x and y, and get y by itself, so subtract 1. And now I need to take the cube root of both sides, and you only need the plus or minus if it's an even index. But since 3 is odd, we're taking the cube root, we don't have to do the plus or minus. So I have y is equal to now the cube root of x minus 1, writing it back into function notation. We have inverse f of x is equal to the cube root of x minus 1. And then one more example. Here we have 5 over x plus 4, and we're going to switch this into a y, switch x and y, and now solve for y. So subtract 4. And what I can do here is I can actually flip these fractions. So just to give myself some more space here, now I would have, this is over 1, so 1 over x minus 4 equals y over 5. And getting rid of that 5, I can multiply by 5 on both sides. And y is equal to 5 over x minus 4. So inverse f of x is is equal to 5 over x minus 4. And there we go. That's our inverse. Now, I'm going to go ahead and flip the page here. And now we're talking about the horizontal line test. So we've already talked about the vertical line test. The horizontal line test checks to see if the inverse of this function is a function. So what I want to do is I want to draw a horizontal line through my function, and if it hits more than once horizontally, then that means the inverse of this graph, the inverse of this function, is not a function. So looking at, I'm actually going to skip this one, I'll do that one last, but looking at this one over here, every horizontal line only hits once. So this is a function. If this is, we'll call this function h of x, then h inverse, or inverse h of x, is a function. Okay. Looking at the next one, all I need to do is draw one horizontal line to know that it hits twice. Even if I drew it way down here, that doesn't matter. Every horizontal line has to work. And so we'll call this g of x. And this means g of x is not a function. Okay. And then going back to this first one, even though there are some lines that work, those are all okay. This single line right here hits at every point. So obviously right away we'll call this f of x. And that means f of x, inverse f of x, is not a function. And actually I should have written here for g of x is inverse g of x is not a function. Okay. Now there's a special relationship with these graphs. F of x and its inverse have a special reflection across the line y equals x. Okay, so if I have a coordinate plane and I have the line y equals x, these two functions would be the mirror image of one another. If this is f of x, this would be inverse f of x. Okay. Not only that, these are also one-to-one functions, which means no x's or y's are repeated. So just in order for it to be a function, we knew the x's couldn't repeat. But now, for it to be a one-to-one function, x's and y's cannot repeat. Okay. And that finishes off section 8 for us. If you guys have questions, just make sure in class to ask your questions.